Hi, this is Joey Gugliardi, and this is my Lab5 recording for automod for ENGI 460. So for my Lab5, I chose to just kind of start off my project in Littlefield Technologies simulation. So for my project, as you can see, or for Lab5, I decided to set up the machine layout that you see here in the picture. So the way I was able to set this up is from what I learned within Chapter 5. In Chapter 5, I learned more about defining resources and how resources are basically machines or operators or anything like that, and queues, and how you have both a wait queue that has infinite capacity and just the regular queue that can have a finite capacity. Learn more about like interpreting statistics and defining downtimes and using business graphics and looking at some of the stats. I learned about using arrayed entities, and that's actually what I used for my model here. And in order to get that loop that we saw, this one was tricky right here because the flow was supposed to be from station 1 to station 2, down to station 3, flow back to station 2, and then out, sent to die. So, yeah, and lastly, I learned about the next of distribution, which I think also could have been used for this, but if then logic had to be used. So, going to the model, you can see I have the queue station wait, and the queue, the actual queue, and then the actual resource or station. And this defines a process 1, process 2, process 3. So I will pull up the palette real quick and show this. So I defined a 3-dimensional process just called pproc. And under loads, I did the receivers, which is what this project is for. And just for this simulation, I did an exponential of 68 minutes. And the first process that starts with is P process 1. For resources, we have 3 stations, and each one has just a capacity of 1. So the number of resources is 3 for the 3 different processes of board stuffing, testing, and tuning at each station. So we'll go back. And lastly, I had to find my queues, 3 for just the queue of the station and 3 for the queue station wait. The wait has an infinite capacity, and the actual queue has, just for now, a capacity of 1. And so I need 3 of those. So I laid out kind of what this would look like here in the graphics. And so now we'll run the simulation. Run the model, yes. And I'll show you the code right after this, but actually, I will show the code first. So if you see you go here into source files, looking at the code, you can see I used move into queue station wait and then queue station, and for each one it's a 3-dimensional process, so it'll start with 1 for the process index, and then it'll use station 1, the process index, and then if the process index is not equal to 3, then it'll send to the top again P process, and process index will increment by 1. Else, this was the tricky part because I couldn't just have it start P process 2 and make it send into die because there was no way to do that. So I had to add the else. Basically, these 3 lines is what P process 2 looks like. And then because each one's -1, so the index is 2, 2, 2, and then lastly it will be sent to die after that. So basically, unless it has hit that 3rd process, it's not going to be sent to process 2 and then sent to die it will just continue to go through. But once it has hit that third process, it'll go back to process 2 and then be sent to die. So just showing this in the simulation. You can see it travels from here to here to here, back up to there. So from process 1, see it again, process 1, process 2, process 3, back to process 2. So we can speed this up in the simulation and view some of our reports. In the process report, we can see the average units in the system and average time it takes for each process, as well as resources. We can see just their utilization, and this would make sense that actually Station 2 would have double the utilization of Station 1 for this simulation. So I'm going to continue to work on this to get it better and to get it prepared for our Project 1. Thanks for watching.